2026 just started and I think it will bring a lot of cool new stuff to the world of 3D printing. To get an insight, I attended Formnext in late 2025 and I think the trends are clear. This year will bring us accessible multi-material printers, stronger filaments, innovative software and much more. So let's dive into Prusa's INDX system, this desktop device that turns any plastic 3D print into a metal part, Recreus' new 2.2mm filament and a new implementation to inject plastic into your infill to get almost injection molding strength at home. By the way, I chose explicitly not to accept any of the sponsorship requests I got from booths at Formnext, as I wanted to share my honest thoughts and opinions about the whole show. If you want to support my work, consider subscribing to my channel free of charge and use my affiliate links and discount codes down in the video description. Thank you. My first day at Formnext started waiting at the Prusa booth for a mysterious announcement only to find out that they cancelled it last minute. Nevertheless, they still had some new things at their booth. The first thing that caught my attention was the new 400° scene extruder hot end for the Core 1 and Core 1L. It's called the HT hot end upgrade and unlocks new materials like PPSCF, PPA and more. It's great and I can't wait to get my hands on one of those, but to be honest, I think it could be a default, especially with the new Core 1L release. I then got aware of the little plus that got added to the Core 1. It's a minor upgrade with some features from the new L, like the automatic top vent operation, a redesigned filament insertion point, and improved firmware. It's mostly printed parts, so you can print them yourself or get an upgrade kit for just $10. It contains the printed parts, updated stickers with the plus, as well as fasteners and other accessories. They also had Proper Printing's XL with his proper extruders and a research project from my friends at ZHAW where they added a pick and place toolhead to the XL. It's still in an early stage, but the printer was able to pick up square nuts and magnets reliably and place them into the prints while printing. I really hope there will be more non-FDM tools for the XL in the future. On Wednesday, in the back room, they finally showed us the long-awaited INDX upgrade for the Core 1. I think it's one of the most exciting new releases. I asked a ton of questions I'll answer here, but feel free to skip ahead if you've already seen my German video about it or simply don't care. INDX for the Core 1 comes with up to 8 tools, 8 nozzles to be precise. Prusa calls the system passive tool changing because the electronics are located in the toolhead and are not swapped along with the tools, unlike, for example, the Prusa XL, which is an active tool changer. You can combine different nozzle sizes. Slicer support is supposed to come with Prusa Slicer 3.0. Currently, the change time is 15 seconds per tool change, with the goal of reducing this to 10 seconds per change over time. A few details, like the calibration, don't seem properly finished yet. The printer at the event had an inductive pinner probe, but the final model is supposed to use a load cell, like an extruder. Tool alignment will probably be done with a pin, as known from the XL. This is what the individual nozzles look like. As said, they have no cable and are heated inductively. That lets them reach a maximum temperature of 300° C. Let's talk about prices and availability. The system is supposed to launch soon in the first quarter of 2026 and was initially available as a Founders Edition directly from Bondtech. Once production is scaled up, the product will move to the Prusa shop. For the regular Core 1, there will be the 4-tool index for €499 and 8 tools for €699, but the prices aren't final yet. They also want to bring the system to the Core 1L as soon as possible. There's 5 cm more space in the X direction, which should allow up to 10 tools to be installed. I was a little concerned about mounting 8 spools on the side of the Core 1, but Sander from Voxel3D told me that there is a better solution. He developed the Inbox, a much nicer and cleaner storage system specifically designed for the Core 1 with INDX. Of course, I also checked out other printers from companies like Bambulab or Elegoo. The Centauri Carbon 2 was more like a prototype. A lot of key information was missing, so I won't go into details here. The Bambulab Vortec in the new H2C also looks interesting for sure, but I'm not really into Bambulab machines, so I can't tell you much beyond first impressions. I'd recommend watching a review from CNC Kitchen or mbox.de. What do you think is more convincing, Bondtech INDX or Bambulab Vortec? Let me know in the comments. One of the most interesting booths for me was Aumatis, a spin-off from Technical University of Munich. They promised to turn any plastic 3D print into a metal part with a desktop machine. The technology used is very well known. It's called vacuum investment casting, or Feingießen in German. Here's how it works. You first make your model from some wax or plastic. In this case, a 3D printed model from PLA would work. You then attach a sprue, put it in a mold container and pour in their investment material. After about 45 minutes, the mold is solid. Then you put the mold into this machine, throw metal in at the top, scraps, bars, whatever you have lying around, and press start. The machine runs the full cycle automatically. It burns out the plastic, melts the metal, and then casts under vacuum to fill the mold properly. They even built in exhaust gas treatment. Time-wise, they claim you can go from CAD to metal part in under 24 hours with only 30 to 45 minutes of actual hands-on work. The sample models at their booth looked super interesting. They had very tiny parts and things like flowers or actual broccoli turned into metal. Part size is limited, roughly 110mm in diameter and 100mm height. They told me that they are thinking about some kind of DIY or maker version to make it even more accessible, even to hobbyists. It's probably still overkill for most of us, but the fact that such a technology is getting accessible in a desktop size is mind-blowing to me. As said, this video is not sponsored by any of the companies featured here. What makes these videos possible are my awesome channel members and affiliate links. That said, I do have a new affiliate discount code. CNC Kitchen recently started supporting the channel and provided a code. If you use JanTec 5 in their shop, you'll get 5% off and I get a small commission. And did you know it's not just their legendary heatset insets anymore? They're also selling high-quality word screws, 3D printer maintenance accessories, and a bunch of useful tools. One thing they added recently is a heatset insert straightener tool, and it's a super clever design. If your insert goes in slightly angled, you can use this to get it perfectly flush. They also have things like a 90-degree installation tip and even a removal tool. If you want to check it out, head over to cnckitchen.store and don't forget JanTec 5 at checkout for your 5% off. In the US pavilion, I stumbled across Z-Polymers with their polymer filament. They're marketed as stronger than steel and still printable on low-cost 3D printers most of us have at home. If you've been following this channel for a while, you know I've tested a bunch of filaments for strength. In the past, PACF was one of the strongest materials I tested, but polymer seems to play in a different league. And on paper, Z-Polymers' own TDS claims their test bars hit 250 megapascal tensile strength and 25 gigapascal stiffness. That's way above typical filaments. On their shop listing, they even call it a replacement for aluminium, steel, PEEK and more. Of course, the price is higher than regular filaments. From their reseller, you can get a 500 gram spool for $275. And at the show, they told me that 1 kilo is $500. So at first you might think this is industry only. But they showed the really clever trick for saving material. The idea is you combine it with cheaper filament and only use polymer where you actually need the strength. So you can reinforce parts without printing the whole thing from the stuff. Sure, the base price is still high, but let's say you're making something like a special quadcopter frame and you only add like 10 grams of polymer in critical areas. That's about $5, totally fine for a special part. And just to be clear, this is not an ad and I'm not trying to sell you this filament, I just want to explain why expensive materials like this still can make sense even for non-industrial users. A different approach than improving the filament itself is improving the printer. FibreSeek ran a Kickstarter for their FibreSeeker 3, a desktop 3D printer that can put continuous carbon fiber into the print. And honestly, it looks like a solid base machine with one really unique feature, a patented dual nozzle design that lays continuous fibers into the extruded filament. Now, I've got mixed feelings about this one. First of all, the sample prints at the booth looked really promising. It does seem like the printer can deliver. Reviews on YouTube pointed out some bad hardware and software flaws. I'd recommend watching YGK3D's video about the FibreSeeker. Digging deeper into their Kickstarter, I found some weird marketing claims like it's 10 times faster or it takes 3 to 7 days for a CNC to machine this bracket with a few holes. And I know that's how marketing works, but I would not buy a machine based on such vague statements. Overall, I feel like their idea is good, but they need to resolve some issues and their target group seems to be a bit off. Most families and hobbyists I know don't really need carbon fiber strength in their everyday prints. Maybe they should consider increasing the price a little and offer a more reliable software so it gets attractive for schools, makerspaces and advanced hobbyists. But maybe I'm being too skeptical here. Let me know what you think in the comments. Let's move from super stiff prints to really flexible ones with Recreus' new 2.2mm TPU. Recreus is a Spanish filament manufacturer that specializes in flexible materials, different TPU types, shore hardnesses, foaming filaments, the whole range. Now, one problem with TPU is that you usually have to print it relatively slowly because it's soft and can buckle on its way through the extruder and filament path. And that's what limits speed. That's why Ignacio, the CEO of Recreus, had the idea just increase the filament diameter. A thicker strand is simply harder to deform, so in theory it should feed more reliably and let you increase the speed. But instead of going to 2.85mm, they chose 2.2mm as a sweet spot. It's still compatible with extruders and PTFE tubes made for 1.75mm filament. The hot end or nozzle needs to be swapped, but there seem to be affordable options for most printers and you can still use them with regular 1.75 filament, so you don't limit yourself to 2.2mm. And it actually seems to work as intended, and I feel like this could shake up the TPU market. What I like is that they had lots of different printers running live at the booth, including Prusa and Bambolab machines. And in my conversation with Ignacio, he mentioned they've printed the filament for thousands of hours with lots of swaps to other materials and no clogs. I'll try the material myself soon, and if you want a detailed video about it, let me know. Next, I went to AIM3D, who came up with Voxelfill. I was interested because I actually tried something similar in one of my videos and did mechanical tests. The idea is just super compelling. Instead of only stacking lines layer by layer, you create little hollow chambers inside the part and then you fill them during the print. Think of it as bringing a bit of injection molding logic into FDM printing. The goal is to achieve less anisotropy and more strength in that direction. That's why I was really excited to see it running on the Prusa XL. Now, the printer on site looked more like a showcase of the workflow as they used a regular nozzle. If the material doesn't really flow into those chambers and properly fill them, the effect is minimal. It's basically just fancy infill. But with the right setup, like a nozzle that can actually dip into the openings cleanly, and the right pressure and temperature settings, this could get really interesting. I hope they release this as a slicer add-on in the future. E3D introduced Fuge, a new high-flow nozzle technology. You probably know Bondtech's HF nozzles, where the filament gets split into 3 strands. Fuge works differently. It squeezes the filament into a flatter shape, so you get a much larger surface area to heat up and melt. To make the material flow, the heat has to reach the center of the filament. And filament is a pretty bad heat conductor. So that takes time, which limits your flow rate, and in the end your print speed. Bondtech reduces the distance the heat has to travel by splitting the filament into 3 paths. E3D increases the contact area by making it wider and flatter. One thing I kept wondering, how do they even machine that geometry? They didn't share details, but my guess is it's made from 2 separate pieces that are pressed together. They didn't bring a lot of info overall, but they did have this modified Rhetoric V minion at the booth, printing insanely fast. I mean, take a look at these motors. That's it with my favorite innovations from Formnext 2025. I don't want to leave the game show hosted by Joel Telling unmentioned. The ticket proceeds are going to the Sanjay Mortimer Foundation and it was honestly really fun to attend. Also, even though the numbers of booths seems to be decreasing and some of the big players didn't show up this year, it's great to see new companies coming in like LDO Motors or iBoss with their smart dry boxes. See you in Tokyo for the Japan Wrap Up Festival next.